Hello all. In this session, we are solving one more derivation, that is centroid on triangle. Okay, go watch the centroid of rectangle. So we got the answer rectangle exactly in the middle. So centroid lies in the middle. So but in triangle, it is not like that. So only one, that is x bar, is will be the half. That is, if the x bar means if you fold the triangle in y axis, the answer will be half. But if you fold the triangle in the x-axis, so that will be not symmetrical. So we need to find the formula for this, right? So we will see the triangle now. So here I have taken equilateral triangle with the base b, and the height is h. Okay, so as I explained in the centroid for a rectangle, here also I am cutting a small strip in the above, small strip. So that will be the b1, that is second breadth b1, and the thickness will be dy. Okay, so as I marked x bar and y bar, see I have marked one capital letter G and marking this will be x bar and this will be y bar, keeping the opposite reference axis. Okay, here whatever the things you have marked in the figure, please explain and introduced. I am going to introduce now. Consider a triangle of base b and height h from the base xx axis. So here I am taking reference as a base as shown in the figure. Let us consider elemental area of thickness dy. As I told, the thickness is dy. The small, I have cut that small strip, that cut piece is called as dA, that is elemental area of thickness dy, and a distance of y from x-axis. So let width of the elemental area will be b1. Okay, neglecting the curvature of the element, just a small curvature is there here, so we are neglecting that and it is considered as a rectangle only. That strip, a small strip, is we are considering as a rectangle. Now fix AB as a base and also the reference axis, that is I'm keeping reference x now. Okay, so before finding anything in the centroid, we have to set one reference x. So here also I'm keeping a x as a reference. Okay, as usual the same steps I'm following from the rectangle, from previous derivation. So first one, total area of the triangle, that is A, capital A, half into base into height, and the area of the elemental area is dA is equal to dy into b1. You can see here base is b1 and thickness is that small thickness, it is dy. Okay, area of elemental area is dA into dy into b1. Next, by comparing the two similar triangles, here you can see top one triangle and the whole one another triangle you can see. Okay, so ABC and EFC, so B1 divided by B is equal to H minus Y divided by H. So if you separating the B1, if you are the transferring all the things this side, so you will get B1 is equal to B into H minus Y divided by H. It will be considered as equation number 1, and substitute this equation number 1 in the dA, that is the elemental area. So dA is equal to dy into b into h minus y divided by h. So after finding entire area and this elemental area, we are moving to the moment. So the moment of the elemental area about xx is equal to dA into y. So dA, please substitute. You have b into h minus y into y divided by h into y into dy. So I am just multiplying with the b, that is by into h minus y divided by h into dy. So here I am just substituting that. So finally you are getting b into yh minus y square divided by h into dy. So this elemental area's moment we got. Now moment of entire area, that is whole area. So for whole area we have to apply the integration for the same, right? We are applying integration for the same moment for the elemental area. So integration will be 0 to h. that is minimum to maximum. I'll just go back to the figure now. Here you can see the total height is h. So 0 to h. I'm taking integration. Just a second. Okay. Summation of ay is equal to 0 to h. So you are substituting this with the moment of the elemental area. So integration, if you are integrating the answer, so you are getting by minus by square divided by h into dy. So after if you are applying lower limit and upper limit, so bh square divided by 2 minus b into h cube divided by 3h. Okay, if you are cancelling hh, so you are getting bh square divided by 2 minus bh square divided by 3. So you are getting like this. So the final answer will be bh square divided by 6. So the moment of the whole area, you are getting bh square by 6. So now at last we are putting this into the formula, right? The centroidal distance y bar is equal to summation of ay divided by a is equal to, so whatever the answer you are getting, so you need to just, I'll go back. Here you can see bh square by 6 you are getting. So same thing I'm applying, bh square by 6. And what is the capital A? Capital A is the b into h, that is half into base into height. So same thing we are applying here. So if you cancel the 2 ones and 2 3s are, it is 6. So final remaining answer is h by 3, that is y bar is equal to h by 3. I'll go back to the figure. Okay, here you can see the y bar which we marked, it is the h by 3. So in this area your centroid is lying, so that is a meaning. So x bar, if you take x bar, no, it is exactly half, that is b by 2. So no need to find the x bar here, we already know it is symmetrical. Okay, if you fold your triangle in the y-axis, it will be symmetric, mirror image. So no need to find the x bar here, so only y bar. So 1 minute. Okay, only y bar, that is y bar we got h by 3. That h by 3 is from the base, this much. So what will be the remaining top one? You just subtract with the whole height. Therefore whole height h minus h by 3 is equal to 2h by 3 from the apex. So apex means the top end of the triangle, and the base means the base 1b. So from the base it will be h by 3, and your centroid lies in h by 3. From the top it is 2h by 3. So please remember this formula to calculate the problems. So all the formulas we need to remember.